Good evening, everyone, or morning, or whichever time zone you're in. Now, let's just do the little technological thing here and share my screen and get this up and running. So I should be able to just... There we go. Hopefully you can all see that. Well, yes, good evening, everybody. And apologies to those who were hoping to be able to come to the RI to see this talk. I guess trains and COVID have prevented that from happening, but technology has made it possible to continue anyway. So it's very nice to see people joining. Okay, the space of possible minds. If you wanted to talk about the mind in the second half of the 20th century, you'd probably have had to have read this book. This is Gilbert Ryle's The Concept of Mind. Gilbert Ryle was a British philosopher. The book was first published in 1949, and it claims to offer a theory of mind. And it's full of fascinating ideas and insights. And it's famous now for attacking the notion, which goes back to René Descartes, that we're made of mind plus body, as if the mind is some sort of ethereal fluid that infuses and animates our physical substance. And Ryle said that this is actually a category error, that it's yoking together two entirely different kinds of entity. It's a bit like saying that there is something that consists of apples plus November. And Ryle derided that so-called Cartesian dualism with the resonant phrase, the ghost in the machine. But there's something odd about the concept of mind, which is that it's all about us and only us. Ryle seems to take it for granted that when we talk about minds, we're necessarily and only talking about ourselves. So the book is of no help whatsoever for thinking about the mind of a dog or of a bat, simply because, Ryle implies, there's nothing really to be thought about. Now, today we're not so anthropocentric, but at the same time, we're not sure how to do better than that because we don't know what kinds of things have minds. I dare say dog owners will argue that dogs have minds, and I agree with them. But do worms and flies have minds? Does an amoeba or a tree have a mind? What can that even mean? Well, I'm curious about this. Had we been in the lecture theatre, I was going to ask for a show of hands, but maybe I'll just ask you to ask yourselves. If I say, do you think that a fly has a mind? Do you think that a tree has a mind? How about a bacterium? The philosopher Daniel Dennett has expressed these intuitions rather wonderfully. He says that if we were to start a sentence by saying, we, my dog and I, no one would find that odd. If, however, we were to say, we, my oyster and I think you can see what I mean. But what are those intuitions and how valid are they? In 1984, the computer scientist Aaron Sloman published a paper arguing that it was time to bring some systematic thinking to this question and to the vague but intuitive notion of mind. So here is the start of Aaron's paper. And he said it was time to admit into this conversation what we had learned about animal cognition, as well as what research on AI and computer science was telling us. Sloman's paper was titled The Structure of the Space of Possible Minds. And he wrote this: clearly, there is not just one sort of mind. Besides obvious individual differences between adults, there are differences between adults, children of various ages, and infants. There are cross-cultural differences. There are also differences between humans, chimpanzees, dogs, mice, and other animals. And there are differences between all those and machines. And he argued that minds exist not along a line that measures maybe something like intelligence, but in a richly structured, multi-dimensional space. Now, this blending of computer science and behaviorism might have seemed a bit eccentric in the 1980s, but today it looks astonishingly prescient. Yet, although the cartography of this space of possible minds has still scarcely begun, I think there's never been a better time to consider what it might look like. Not only, for example, has AI at last started to prove its value, But there's a widespread perception that making further improvements and getting to anything like artificial general intelligence, anything that might be compared really with human intelligence, will require a close consideration of how today's putative machine minds differ from our own. And this is actually a very timely moment to be thinking about that question, which I will return to briefly later, because I'm sure many of you will have seen the discussion excited by the claim of a Google engineer last week that his AI had sentience. Our understanding of animal cognition has also got a lot richer in the past 2 decades or so, in part because of the new possibilities that neuroscience and information technology have opened up. These days, it's quite common, routine even, to find child psychologists talking to roboticists and computer engineers, and neuroscientists talking to marine biologists. And we've got some of the conceptual and experimental tools to start mapping this landscape of minds. Well, first of all, we'd better ask what we're looking for. What is a mind? Well, there's no scientific definition that will help us here. Much of the vast literature on the philosophy of mind barely defines its terms at all, as Gilbert Ryle didn't feel the need to. They take it for granted that we're talking about us. Daniel Dennett presents a nuanced exploration of what non-human minds might be like in his 1996 book, Kinds of Mind. And yet he too begins by suggesting that whatever else a mind is, it is supposed to be something like our minds. Otherwise, we wouldn't call it a mind. Mind is actually one of those concepts, like intelligence, like thought, in fact, like life, that sort of sounds technical and scientific, but and therefore should be definable, but in fact is colloquial and irreducibly fuzzy. But I don't think that a workable definition of mind need be impossible, so long as we accept that we're not going to get one that is completely scientifically airtight and rigorous, or in fact philosophically so. So I would put it like this. For an entity to have a mind, there must be something it is like to be that entity. So I don't believe that a rock has a mind, because I don't think a rock has any experience. I don't think it means anything to say that being like a rock is to be like anything at all. Well, that's my opinion. There are some who would take issue with it, and maybe we'll talk about that later as well. But how about a bacterium? Is there something it's like to be a bacterium? Wherever you stand on that question, I guess you'll see that at some stage in the complexity scale of life, there must have arisen entities for which there is something it is like to be them. I think that most people today would be ready to accept that there is something it is like to be an orangutan, for example. But I think it makes sense to speak not in terms of things that absolutely do or don't have minds, but of mindedness, to acknowledge that minds aren't all or nothing entities, but are matters of degree. And I want to begin to illustrate that by showing you a couple of previous efforts to say what this mind space might look like. A simple but an ingenious way to draw that map was devised by the American psychologists Daniel Wegner, Heather Gray, and Kurt Gray, in no relation as it happens, in 2007. They simply asked people about other minds. They said, what attributes do you think the minds of these entities have? So they questioned about 2,500 participants about the perceived mental capabilities of humans, of other animals, and other entities like robots, companies, and supernatural agents like God and ghosts. Now, surprisingly, they found that the responses they received could be boiled down to a space of possible minds that had just 2 key attributes, which they labeled experience and agency. And here, experience meant a sort of inner life. The mind has a capacity, say, for hunger, fear, rage, pleasure, joy, or more generally, a sense that there is something it is like, something it feels like to be that sort of mind. Agency, meanwhile, refers to the ability to do things and to accomplish goals, to possess memory, to plan and to communicate. So this is really then a space of possible perceived minds, what we humans imagine as the dimensions of mind. And it can be displayed as an ordinary two-dimensional graph on which each entity is represented as a data point with a certain amount of these two quantities, experience and agency. So here it is. And you'll notice that humans are evidently regarded as following a path through this space in the course of their lives. So there's a data point here for an embryo, a baby, a child, and adults. So babies were rated on average as slightly higher in experience, but much lower in agency than adults. Everything for a baby is intensely felt, but they can't get much done. And then children are intermediate between the two. Now, if entities can feel, if they have experience, then we tend to grant them some kind of moral consideration, some sort of moral rights. We consider that we have a duty to recognize and to respect that experience, or at least we should do. If, meanwhile, they have the ability to act, to cause change in the world, then we're inclined to give them moral responsibility, a duty to execute those actions in a way that respects the moral rights of others. So by this measure, humans incur both moral rights and moral responsibilities. And we seem to perceive robots here as having responsibilities because they have agency, but not rights because they have no real experience. You might say that it matters what they do to us, but not what we do to them. And I think that one of the most wonderful explorations of the complications of that position are in this the new novel by Kazuo Ishiguro, Clara and the Sun. And really, this perception of the difference of robot minds stems from our view of what manner of mind they possess. Another attempt to plot out this space of possible minds has been made by the neuroscientist Christoph Koch, and his mind space is also two-dimensional, and it has different coordinates of intelligence and consciousness. So here it is. And again, you see humans are considered to exhibit the greatest simultaneous component of both of these attributes. And then other animals have some degree of both, although, primitive creatures like jellyfish don't have a lot of either. And so they tend to fall on this diagonal line so that one increases in proportion to the other. Today's computers and artificial intelligence systems have, in this view, plenty of intelligence, but negligible consciousness. And in Christoph's view, that's unlikely to change anytime soon, perhaps ever. So, as I say, here again, humans appear at the top right of these plots. They're represented, they're considered as the exemplars of the key attributes of mind. All these other minds are being assessed according to how they compare with ours. Well, that's just the way we are, right? We're egocentric. So let's begin by thinking about the human mind, not to cut us down to size, but to get a clearer view of what the bit of the landscape around us might look like. The philosopher Ned Block has suggested that there are two key components or attributes of the human mind. I guess he sort of takes consciousness for granted, and he says what features in the human mind is intelligence and intentionality. So here, intelligence is an information processing capability again, one that turns a stimulus into a behavior, while intentionality supplies the purpose and the motive for that behavior by relating it to the world, the environment in which it exists. Dan Dennett argues that to have intentions at all means that a mind must be a generator of expectations and predictions. What else is an intention, after all, but a wish for a certain imagined outcome of events in the future? And Dennett says that the mind mines the present for clues, which it refines with the help of the materials it has saved from the past, turning them into anticipations of the future. And then it acts rationally on the basis of those hard-won anticipations. This view of the human mind as a predictor suggests how it differs from a machine-like stimulus response system. That's simply what an intelligent system does in Ned Block's classification. The simplest organisms, like bacteria, often show behavior that's a bit like that, that is hardwired. These organisms have a very limited repertoire of actions that are generated reliably and predictably by certain stimuli from the environment. Now, I should say even bacteria are capable of more than that, but it's not too much of a simplification. But our minds, as well as those of other animals, aren't simple stimulus response circuits for creating action. They're the alternative to that kind of automaton-like behavior. In other words, you could say that minds exist to free us from that fate, that they free us from our genetic hardwiring by allowing actions that aren't already pre-programmed into us. The amazing thing about humans is not that our genes affect how we think and how we make choices. Of course they do that, but that so much of our behavior seems to escape their dominating influence. Complex minds have a vastly expanded behavioral repertoire that can be fine-tuned and adjusted and, crucially, improvised to new circumstances. And this makes evolutionary sense. If evolution wants to give a creature a lot of behavioral options because the creature exists in a complex environment, it can either invest in hardwiring a response to every foreseeable circumstance, or, and this seems the most efficient route in the end, it can build that creature a mind. In his book, The Selfish Gene, Richard Dawkins talks of minds sometimes rebelling against genes, doing things that don't promote our own survival. And you can sense perhaps a little surprise or even indignation in that ability. But I'm not sure that that's the right way to see it. While it's common to regard the brain as a machine encoded and guided by genes for making decisions connected to our survival and our propagation, I think instead of the genes as the parents and the mind as the child. So I think like this: the genes say, well, look, we can't tell you what to do for every decision you're going to face in life. There are just too many of the decisions, and there's too much to take into account, and sometimes even we don't know the right answer. So what we're going to do, and all we can do, is to bring you up to be an independent thinker who can learn good ways of behaving, good rules of thumb. But the genes add, never forget this, my child. Your aim is always to survive and reproduce. And then the mind child goes out into the world. And much later, the genes come along and see how their child is doing. And look, the child is sitting there devising the theory of general relativity. And the genes say, what the heck are you doing? How is that going to help you with the objectives I gave you? And the mind replies, oh, I don't know. But you see, you gave me these capabilities to do stuff like this, and I quite like it. This is what's so odd about our minds. The intelligence we're endowed with is so broad. And that's not a boast on behalf of the human species. I'm the first to admit that we do a lot of dumb things, right? But it's frankly rather bizarre that a brain adapted on Darwinian tracks should be capable of producing the theory of general relativity. No one knows why evolution made such a cognitive investment in us. But one prominent idea is that it was motivated by the mental demands that our ancestors experienced when living in a community with others, that what distinguishes us most in the animal kingdom is social intelligence, the ability to respond to and get along with others. Other evolutionary biologists think that, in fact, the richness of human cognition had less to do with a generalized ability to socialize and more with the specific social challenge of finding a mate. In other words, that it's a product of sexual selection. I can't quite believe that I used this image, and I apologize for it, but in a way these stock images tell stories, cultural stories of their own. I think I found it by searching for something like sexy professor. So here you go. The idea is like this: a complex repertoire of behaviors might persuade a potential mate that this individual is likely to be good at the survival game. So in this view, human intelligence might be a bit like the peacock's tail or the stag's antlers, a trait that got blown out of all proportion relative to what was strictly needed. You might say it's a case of, and you have to imagine one or other of these people saying, look at the size of my cognition. Others think that the key to human intelligence is not so much biology, but culture itself, that our intelligence took off in parallel with our ability to pass on learning, skills and technologies to successive generations. And really that's a form of, you could see it as a form of Lamarckian evolution, that we acquire skills during our lives and then we are able to pass them on to our offspring. After all, what distinguishes us most from other animals is arguably not our basic cognitive skills, but the complexity of our societies, and in particular of the languages that we use for this kind of cultural transmission. And this open-ended, imaginative nature of human cognition might be just what we needed to cope with the greater part of our existence, of what that has always consisted of, which is choices of what to do that never end and that, in all probability, have no absolute right answer. So living isn't a computation, it's a process, a constant flow of interrelated decisions and actions and anticipations and emotions that feed back on one another. And so the mind is more like a pilot than a computer. And the task of the pilot is not to solve reality, but to land the plane. What it needs to do that is a representation of the world it must navigate. And that representation needn't be perfect. In fact, it can't be. It can never be perfect, as we never have perfect information. It must merely be good enough. And likewise for our decisions. They're not computations of some optimum action, which is likely to be very time-consuming to find, even if it exists at all. Instead, our minds must and do use shortcuts and rules of thumb to find ways to make decisions that we hope are, on the whole, going to be good enough. The Harvard psychologist Elizabeth Spelke has proposed that we achieve this using a small number of core knowledge systems. One of these, for example, gives us the ability to conceptualize objects. We think of, we can imagine things that hold together as single entities and which persist over time, whether we continue to perceive them or not. And Spelke says we also have a core system for space, for handling spatial matters such as distance and orientation. We know that some things are nearer or farther from us and that they sit in particular directions relative to us. Other core systems deal with actions, with our ability to affect things, and with number and quantity. And Spelke suggests that there's a fifth core system that relates to social interactions, that it supplies the basis for our intuitive psychology, which recognizes other beings as agents with their own intentions and goals, which might or might not align with our own. This is really what psychologists call a theory of mind. And by that, I mean not a theory about what minds are or how they work, but our own sense that others have minds at all, and that they probably work something like ours. So here then is what I think seems to characterize the human mind. It evolved to enable more diversity of behavior in complex environments than you could realistically achieve from stimulus response hardwiring. It solves problems that are not computable. And I don't necessarily mean that in the technical sense, although some people have connected consciousness with Gödel's theorem, if you know about Gödel's theorem, the fact that there are some problems that we can see are true, but that are formally impossible to prove within an axiomatic system. So there's something interesting going on there. And one suggestion is that perhaps we use emotions to solve those sorts of problems. But we do so, we make these decisions and solve these problems by constructing a representation of the world we experience, and from that, possible futures. And our minds exist and know that they exist in relation to other minds. So I'd suggest that maybe here we have some sort of schematic outline for thinking more generally about what minds might be, or at least what evolved minds like ours might be. Now, Charles Darwin had no doubt that other evolved minds, those of other animals, exist, that animals do have minds. And I think few animal behaviorists would now dispute that this is so, especially for other primates, that they would agree that primates seem to be alive to sensation, to feeling, to emotion, and most probably to some degree of consciousness. The nature of the animal mind defines what is called its Umwelt. In effect, this is the world that the creature inhabits, characterized by certain needs, by certain concerns and capabilities. So the Umwelt is really what stands out for the animal in its environment, the things it notices and attends to. Smell is a much smaller part of our Umwelt than it is for dogs. And by that I mean not just that we're less sensitive to it, but also that it means less to us. In the Umwelt of a slug, a lump of flint, and I admit I'm guessing here, merely represents another obstacle to be navigated, whereas for our ancestors it represented a potential tool. The Umwelt includes things that we recognize as distinct objects, or that other animals do. So for us, we recognize a woodland path as a thing, whereas for a vole, there are just open spaces, which are dangerous and maybe to be avoided, and more vegetated spaces, which tend to be safer. The Umwelt of a European robin includes some kind of awareness, and we don't really know what that means, of the Earth's magnetic field. And the Umwelt includes an organism's conception of a kind of intuitive physics, of things it believes can happen, if you like. And it's from the Umwelt that a creature builds its conception of the world. It's really the organizational framework of its mind, what in the world that mind finds meaningful. The Umwelt of a flying creature, like a bird, recognizes spatial possibilities that are alien to us. And in fact, the avian world, the bird world, is one of the richest repositories of other minds. The cognitive skills of birds are astonishingly diverse. Among them, we find arguably some of the best claims for non-mammal consciousness, as well as examples of artistry that raise questions about the possibility of animal aesthetics. And we find some of the most complex vocalizations in the natural world, and prodigious feats of memory and inventive tool use. Now, I think we'd find bird minds scattered rather widely through the space of possible minds. Some birds seem to be mind blind to things that dominate the Umwelt of others. And even sometimes fairly closely related bird species can show very different cognitive abilities, which show that minds don't come as a package that is simply passed down with minor modifications down the evolutionary chain. Rather, minds are strongly and intimately shaped by the specific evolutionary niches and strategies that are adopted by the creature that have them. Now, one of the most striking attributes of bird minds is tool use. Aside from several primates and elephants and cephalopods, like octopuses, birds are the only other major group of tool users, and the champion of avian tool use are surely the corvids, especially this one, the New Caledonian crow of the South Pacific. It's possible that some of this tool use is guided simply by trial and error. So they might rely less on building up imagined scenarios, kind of as though they're thinking, hey, if I use this stick, I bet I could get at more bugs. And more on just past experience of playing around with that object. So it's more like, when I did this, that happened, so I'll do it again. But it's not all try and see. There do seem to be some general principles behind bird tool use based on a kind of intuitive physics. And these concepts that birds have are often probed by studying how birds try to, for example, retrieve food from within tubes by pushing or pulling on piston-like tools. And I wanted to mention that a lot of this work, some of the finest work in this area has been done in the Animal Cognition Lab of Nikki Clayton at Cambridge. I want to mention that because the university has just decided to close that lab down, to the dismay of, I think, the entire animal behavioral world. And it does seem to me to be an act of intellectual vandalism to do that. A key question is whether tool use in animal implies that they see any causal connection between what they do and what results. So this is really the difference between an action that is understood to cause a result in a mechanistic way and an action that is merely correlated with the outcome, that kind of summons the outcome in a sort of ritualistic way. So in other words, the distinction between these two possibilities is really a distinction between different modes of thinking that are produced by different kinds of mind. And one of the key distinctions is whether birds can carry out multi-step tasks, whether they can keep an ultimate goal in mind. So in contrast to what's been a common view that other animals just exist in a perpetual present, the ability to carry out multi-step tasks seems to demand some concept of future consequences, some notion of if I do this now, it'll let me do that later. And this seems to entail some kind of representation of possible future scenarios and of their outcomes. And such imagining of the future seems to be at play, for example, when some birds cache food, when they leave little stores of food stashed around for future use. And the most accomplished birds in this arena are the scrub jays. So in one experiment on scrub jays, they were kept in cages that were divided into two compartments. And each morning, the birds were moved into one of those two compartments. And one of them always the same compartment, contained a breakfast snack, whereas the other was just empty. And the experimenters allowed the birds to familiarize themselves with this and then to feed on nuts the evening before, as many nuts as they wanted, and then they could store whatever was left in a cache in one compartment or the other. And they found that the scrub jays always stored what was left in the compartment that they had learned from experience would otherwise be empty the next morning. Just in case, you could say, they were put in that one. It's hard to see how they would have made that choice without some anticipation of future scenarios. Now, if we want to explore further in Mindspace, the most intriguing minds in the animal world are arguably those of the cephalopods, such as octopuses and squid. These are invertebrate mollusks. They diverged from the lineage of vertebrates that we are in 600 million years ago or so. That's before the Cambrian explosion. Octopuses do seem smart. They possess memory. They seem to have problem-solving ability. They even have what looks to us like a kind of cunning and personality. They've got an exploratory nature. They don't recoil from unfamiliar experiences like many animals do, but seem to engage with novelty in an open-ended way. They figure out how to unscrew jars, how to navigate mazes. Some have proved able to fuse laboratory lights with jets of water. They don't like bright lights. And others have proved able to escape their tank, seemingly just at the moment that their human wardens aren't looking. They appear to hoard items that they find interesting, even if those items seem to lack any obvious use. The philosopher Peter Godfrey Smith, whose book, Other Minds, that is mostly about octopus cognition, I would really recommend everyone to read. It's fantastic. Peter Godfrey Smith says that octopuses, like us, seem to have a mental surplus, that they have far more mental capacity than they should need, or than they seem to need. If so, it's unlikely that arose for social cognition as it might have done for us, because octopuses are fairly solitary animals. So it's tempting to regard cephalopods as having oddly sophisticated means of expressing themselves, while having rather little to actually express or anyone to express it to. And if our habitual division of into mind and body looks unhelpful for understanding human cognition, it really makes no sense at all for cephalopods. The body has, if not a mind of its own, then what look like a set of sort of proto-minds in each arm that make their own decisions. So the octopus does have a centralized brain in its head, but more than half of its neurons are in the arms. And some of them are gathered into clusters that might have a rudimentary brain-like capacity and certainly seem to operate fairly autonomously. The limbs even seem to possess some form of short-term memory. We're not even sure if the octopus knows what its limbs are doing. And as a result, octopuses may lack any strong sense of self at all. Perhaps to some degree, they just kind of watch their limbs perform as if watching another creature in action. So they challenge the notion that experience must be a tightly integrated whole. To wonder what it's like to be an octopus might then depend on which part of the octopus we ask. One theory is that the ancestors of the cephalopods actually had two entirely separate minds, one for controlling the eyes, one for controlling the arms, that eventually merged. At any rate, cephalopod minds represent an entirely distinct evolutionary experiment in building minds from ours. The common ancestor that we share with them probably wouldn't have had much of a mind at all. It seems to have been a kind of flatworm that did have a rudimentary nervous system for coordinating its actions. So it did have nerve cells. And while these cells might be the building blocks of biological minds, that's probably not what they originated for. Neurons may be cells that are adapted specifically for transmitting signals between other cells rapidly and precisely over long distances. And that's something that would have become necessary once organisms had multicellular bodies and had to coordinate different parts of their body. And neurons do this electrically. They build up and transmit electrical potentials, voltages, by controlling the flow of electrically charged ions across their membranes. And some researchers suspect that this electrical sensitivity, what physiologists once called irritability, imbues nerve cells with the ingredients of sentience itself. These, incidentally, are my own nerve cells. They were grown for me from a little piece of my shoulder, and that's another story entirely that I won't have time to tell you about, but it's always quite nice to see them. The information expert, the informatics expert Norman Cook has suggested that a nerve cell, by opening up its membrane to the flow of ions that creates this voltage and supports this action potential that travels down the axon, by doing this, it breaks the hermetic seal by which living cells distinguish their inside from the outside. And that this opening up to the environment is in itself enough to generate a kind of proto-feeling. So in this view, perhaps there might even be something it is like to be a single neuron, and that brains and minds and cognition are, in this view, an aggregate of atoms of sentience. And some biologists now argue that mindedness doesn't even require you to possess neurons at all, that it may be an inherent property of most, and perhaps all, living systems. Plants, for example, do some things that minded creatures do too. They have goals. They're flexible and adaptive in their means of attaining them. They make decisions, and they sometimes do so by learning and by a kind of Pavlovian conditioning. Some scientists have argued that we need a new discipline they call plant neurobiology. And some even argue that plants can experience something like pain, a feeling of aversion towards things that threaten their integrity and well-being. And here I'm showing the so-called sleepy plant, Mimosa pudica, which responds to touch as if sort of defensively by curling up its leaves. As ever more evidence accumulates for the range of cognitive-like faculties that plants possess, advocates of plant neurobiology say that to deny them intelligence and even mind can look increasingly like the sort of special pleading that we once used to elevate our own species above all others. Some argue that mindedness is, in fact, a fundamental property of all living things, and this is a position called biopsychism. In this view, all organisms have minds of a sort, merely by virtue of being alive. Well, what plants, I think, surely do show is agency, the ability to act on the environment and on itself in a goal-directed manner that isn't fully prescribed by stimulus-response rules. So that's what I would consider agency to be. And the claims of biopsychists seem to me to be perhaps trying to fill the gap left by our lack of a good understanding of how agency arises in biology and perhaps beyond. not all agents, I think, have minds, but all minds have agency. And I'd argue that one obstacle hampering our understanding of minds is, at the most fundamental level, is the lack of a proper theory of agency. And this is an article in which I argued that it's time to really start thinking about that. And some researchers already are. So I hope you might see that if these considerations about mind are right, then not only have we not yet come close to making machines with minds, but we're not necessarily even heading in the right direction to do that. There's a long history of overblown claims that preceded the one that I mentioned earlier by the Google engineer, that we already have sentient AI. This is a link to an article, a New Statesman, in which I talk about that claim, as you can see, skeptically. And there's a long history of this sort of thing. Early predictions in the field of AI in the 1950s, 1960s were that we would have fully intelligent machines within just a few decades. I think we can see that claims like that were now motivated by a woefully inadequate view of what human-like intelligence and cognition really are. And I think that was reflected in the notion in those days, and perhaps to some extent even now, that the highest expression of our minds is exhibited in something like our ability to play chess. It's often said that today's AI finds easy what we find hard, and vice versa. And in particular, that AI lacks what we would regard as common sense. I think a better way to express that is that AI uses a different mode of cogitation. You might say a different mode of mindedness. That what we call common sense is largely an adaptive, intention-driven form of behavior that's motivated and informed by our internal representations of reality, by our intuitive physics and our intuitive psychology. And these aren't things that seem likely to just appear in AI if we go on making it more complex, giving it more processing power, more sensory inputs, more layers of deep learning or whatever. They've evolved in us for adaptive reasons. And if we want machines to exhibit them, then we're likely to have to put those features in by hand. Perhaps one of the most interesting questions is whether they can arise at all without any degree of self-awareness. I mean, we can certainly imagine making excellent deep learning mimics of human behavior that, once trained on enough data, can pass the Turing test in human conversation. That's precisely what this debate was all about. Or, you know, can debate with us and so on, while still remaining zombie machines without a flicker of consciousness. We're arguably at that point already, or soon will be. What's less clear is that we could ever make machines like that more than one-trick ponies, devices built for a single task, at best with a very narrow range of abilities. If we're to overcome that narrowness, and with it, the accompanying brittleness and vulnerability to what look like absurd mistakes and misjudgments that even things like self-driving cars rather alarmingly make, that might not come from just tweaking the system a bit. It may be that in order to get anything more general than that, we'll need to start making entirely different kinds of device. And at least that is what some researchers in AI are starting to expect. Well, I wish that I could wrap up now with drawing you a picture of Mindspace and pointing to our place within it. But such maps as we can currently offer are a bit like medieval maps of the world. They're reasonably reliable in our own neighborhood, kind of sketchy in the lands bordering ours, and little more than guesswork for distant realms where perhaps we depict fabulous beasts that we're not sure actually exist at all. The best I can do right now is to suggest just some of the possible parameters or features of this multidimensional mind space. And I've just listed a few of them here in no particular order. So however unsatisfactory this effort is, I hope at least that it helps us to refine the notion of what a mind is. I mean, I said earlier that a mind, in my definition, must possess a what it is like, some kind of feeling. But what is it really that this mindedness exists to achieve? What's the purpose of it? If I were to pick one central notion for what characterizes the role of mindedness, I put it like this, that minds seek what is meaningful to them in the universe. You see, the strange but inevitable truth about the nature of reality is that it doesn't have a unique form. It has to be interpreted. And what the human mind perceives is not the world, but a reduced internal representation of it that is useful for us. Our meaningful information, our personal reality, is selected from much, much more that is out there, and selected not arbitrarily, but in a way that aligns sufficiently with what actually transpires, whatever that is, in the physical world, whatever that is, to enable us to get along within it. Our minds ascribe that meaningful information with value. What is meaningful, because it's more useful, is awarded more value for us. We want it often. It may be that the emotions are partly what help us to construct and calibrate that value scale. So what determines the topography of this mind space? Where is it populous? Where is it barren? We don't know the answer to that. We barely even understand the question yet. But the shape of this space, I think, is surely not arbitrary. I think it will permit some kinds of minds, but not others. It's reasonable to think that minds, at least on our planet, come from a space of possibilities in which certain attributes are indispensable or inevitable, that they must, for example, possess some degree of memory, or a limited range of sensory inputs, or limits on the ways of integrating them. There's only so much reality that these minds can handle, you might say. So, it may be that minds that don't have those attributes simply can't exist or evolve here, at least. We don't know what dictates those options or limits, but I think it probably has something to do with information itself, with how it can be filtered from the environment, how it acquires meaning, how it can be most efficiently organized and used, what types of embodiment enable its collection and use. To understand minds at their core, I think might involve rooting around in theories of information. In any case, I think there is really no more profound challenge than this. It's one of the deepest mysteries in science that the universe can generate a capacity to know itself. You see, there's nothing in the fundamental laws of nature, so far as we currently know them, that hints at that capacity. To me, this seems much more remarkable than that those fundamental laws predict the existence of black holes. Black holes were predicted from those fundamental laws. No one has predicted minds from first principles. And yet I suspect that mindedness, as much as life itself, is an inherent characteristic of the universe. Whether it's rare or common within it is, by comparison, a minor question. That conscious matter exists at all, I think, has to make one wonder if there is at root some feature of information itself that will render that inevitable. Or perhaps we might turn that question on its head and wonder whether the laws are themselves contingent on the kinds of minds that perceive and articulate them. This could be one of the practical benefits of having a better view of the space of possible minds. It could broaden the horizons of our own minds, freeing them from the straitjacket of our own convictions and the blind spots in our perception. I don't think we should take it for granted that octopuses or bees or bats carve up the world in quite the same way that we do, and they're just our neighbors in Mindspace. This is precisely why the biologist J.B.S. Haldane advised humility about how we imagine and depict the world in our schemes and in our sciences. He wrote, "We're just getting at the rudiments of other ways of thinking. I do not feel that any of us know enough about the possible kinds of being and thought to make it worthwhile taking any of our metaphysical systems very much more seriously than those at which a thinking barnacle might arrive. As we extend our sensory modalities artificially, we realize just how much we've been missing. X-rays and radio waves, gluons and gravitons, dark matter and antimatter. As Haldane famously went on to put it, my suspicion is that the universe is not only queerer than we suppose, but queerer than we can suppose. And he said, for that reason, our only hope of understanding the universe is to look at it from as many different points of view as possible. For that, I think we may need those other minds. Thank you very much.